If you have an array, different things you can do with it. One is you might want to find the maximum value in it. You might want to find the lowest value. You might want to find the average value. You might want to find all the count of how many values match a certain data type, right? Now, we had cool little commands for all of those in Python. We could do this. Say you had a list, you know, in Python and it had some numbers in it. And if you wanted to, you could, you know, print l.count, and if you passed in 12, it would tell you how many 12s were in it, right? Or if you printed, sorry, l.count like that, and you could print the max of the list. You could print the minimum of the list. You could print the total, the sum of the list. And then if you wanted the average of it, you could print the sum of it divided by the length of it, right? Well, we're going to write some of this stuff by hand rather than having these built-in functions. So to find the highest value in the array, if I was going to find the one of y'all with the maximum age, what I would do is go to the first person in the list and say, okay, what's your age? I'm 23. Okay, I go, all right. And then I keep going to each person and saying, what is your age? And if your age is higher than the one on my paper, I replace it with your age. So I'd ask you. You go, no, you're not higher than 23. You are. You're 38. Okay, right, 38. Nope, you're not higher than 38. Nope, you're not higher than 38. Aha, you're 45. So I write 45. And I keep getting all the way to Kathleen, and she's 112. So I write 112. We didn't say what year that's speaking of. Okay, so that's how you find the highest value in an array. Finding the lowest is the same, right? Except I write down the first value, 25. And then I keep checking to see if anybody's lower. Are you lower than 25? Nope, you're not. Yes, you are. You're 14, so I write 14. And I go all the way to the end looking for the lowest value. So, this is written, I don't know why they did it that way, right? Because we could have just put the int right here and then taken that out. Right, that's how we would have written it. But so you have highest. Highest is equal to the first number in the array. Then you iterate through the array looking for the higher value. Now, if we use a range-based for loop, it'd be even easier, right? Because the syntax for the range-based loop was nice. This one didn't even tell us what the size of the array was, so we would have had to calculate that or whatever. Range-based for loops don't need that. So you could do something like this: int highest is equal to the first element of the array, right? AR subscript 0. And then for int value v in the array, not the word in, wrong language. If highest is less than that new value, then highest becomes that new value. Right? That would do it. That would find the highest in the array. What changes are we going to make to look for the lowest other than change the word high to low, right? Int lowest is equal to array subscript 0. For every value in the array, if the lowest, what am I going to put here? I'm not going to put less than the value. I'm going to put greater than, right? So if the lower, if what's on my paper is higher than what I'm looking at, I need to replace it. So that's our code for finding the highest and finding the lowest. What if we wanted to match a certain value? Like we wanted to count how many 3s were in the name. I mean, in the string of numbers or something like that. Well, we would declare a counter. And then each time we found a value for every v in the array, if it matched our target, right? If v is equal to our target, we would increment that counter. Like that. What if we wanted to sum all the values in the array? I think honestly I wouldn't make it an int. I'd probably make it a float or a double. but whatever. An int would work fine since it's an array of ints. So int sum is equal to 0 for every v in the array. Sum plus equals v. What if we wanted to count? Sorry, not a count, a length of the array. Well, this is kind of silly to use a range-based for loop just to return the length, but it's pretty reliable. So len is equal to 0, and then for every value in the array, add 1 to length. Right? There we go. So those are 4 of our functions. This is, or even maybe higher, more. This is the max function. This one gets us the minimum. This one gets us, this is a count function. This is a sum. And this is a length. And then if you wanted the average, what do? You calculate the sum, you divide it by the length of the array. So let's write some C++ code. Maybe we could stick this stuff in a class. I don't know if we're feeling that ambitious. Maybe we'll just make it functions in a global variable. Or maybe we make them functions where you pass in the array. That's the more correct thing to do. Let's do that. So what we're going to do is we're going to write a set of functions. You know, one called max, one called min, one called sum. And what is it going to take? Its parameter is just going to be an array of ints, or an array of floats if that's what we wanted, right? But this one's going to be an array of ints. New source file, add new item. All right. Using namespace, int main, system pods. All right.
Return 0.
Return. Thank you. Thank you. Thank you. Knew something was wrong. All right. So let's declare an array of numbers. Int nums subscript in subscript equals curly brace, and then type in a series of numbers separated by commas. However many numbers you want. Make sure that there are some duplicates. So here's what I want to be able to do. I'm going to write some function calls, but we haven't written the functions yet, but this is just a kind of prototype the way we want it to work. So how about int max num equals max subscript nums, right? Just like it was Python, but it's not. We're going to have to write that function ourselves. And it was called sum anyways. No, max, right? Okay, and then int min num equals the minimum parentheses nums. Int sum sum num equals the sum of the nums. What else were we going to do? We were going to do a max min sum. I can't believe I'm having to go back and look. A count and a length. So the length len num is equal to len parentheses nums. And one of those numbers that you put in more than once, I don't remember which one it was, so I'm going to just do it right now. I'm going to put in several threes. Okay. int count is equal to count in our nums list the number of times we can find a 3, or whatever your favorite number is that you had multiple times in your list. So we've got 5 functions to write there. But we saw from the notepad that they sure do look alike. So let's do the max first. Int max, and it takes as its parameter an integer array, so int nums, angle brace, into parentheses. So int highest equals the first element of the array, nums subscript 0. By the way, that'll blow up if you pass in an empty array of no length whatsoever, but I really can't think of what we could do to fix that, so I'm going to leave that idea alone. All right, and then you have your for loop, right? For int v colon nums, for every value in the nums list, nums array. Why are you giving me grief there? Error. This range-based for statement requires a suitable begin function, and none was found. Oh, yeah? What if we had done that here? What if we had done that? Oh, what do you know? Max is... No, all right. Anyways. Alrighty. Did I just learn something new? Did I just learn that you can only use a range-based for loop if you're in the same scope as the variable in which it was declared? That would be horrible. Give me a break. This range-based for statement requires a suitable begin function, and none was found. What if we passed it in by reference? Would that fix it? Let's find out. Let's turn in nums into a reference. Well, that was a vain hope. Well, I'm doing something dumb and I don't see what. I guess I got ambitious by wanting to put it all in. Arrays as function arguments. Well, I guess that's why we keep lecturing to ourselves that we always keep the size of it as a constant, right? And then we pass that size around. So we're not going to be able to do our cute little range-based for loops if we do it like that. We're instead just going to have to write the old style. So, okay, fine. Int nums, comma, int size. We need that. You can't believe how much that irks me. But then again, that's why we have Java and Python to handle these kind of oddities that you find in C++. C++ is a great language. It's very fast, but the other ones have syntaxes which have improved upon it. Okay, so for int I is equal to 0, I is less than size, I plus plus. If highest is less than nums subscript I, then highest equals nums subscript I. See, it was so much cleaner when it was just a for loop. I mean, a range-based for loop. And then we're going to return highest. All right, right now we can't test our code because we've only written one function, and we're not even invoking it correctly. But we have 5 function calls. We're going to go back down to main, and we're going to comment them all out other than the call to max. So go down to main and comment out all your functions except for the call to max. And we changed max, right? There's an error there. What is that error from? Because it also requires a size parameter. So we need to determine the size of the array. And you need to do it in the same scope that the array was declared in. So int size equals, and we're going to do that size of divided by size of business. Size of nums divided by size of the first element in the array. Nums subscript 0. And then when we call max nums, we're going to pass the size in. Now you see all these calls that we commented out? We know we're going to need to pass a size in for those as well. So even though they're in comments, I'm just going to type that. Nums comma size there. Nums comma size there. Nums comma size there. And I don't even feel like writing a count function at this point. I'm just going to delete that one. I'd better do it with a range-based for loop. All right. Okay, this one's moronic though, right? We don't need that one. Why do I say that? Because if we already know the size, we already know the length. They're the same thing. So we're only going to wind up having written 3 of these functions. Maybe then we'll loop back and do the idea of the count or whatever, but I think this is enough. Okay, run it, have it print out the array with a loop, but let's put that in its own function. So let's make a function that prints out an array. So print nums comma size. But I'm going to have to add a print function, right? So above main, we're going to declare another function. Doesn't need to return anything, so it's going to be void. Void print, and it takes an array. So int nums subscript in subscript, comma, int size, int space size. And that's just going to be one of our cute little for loops. But let's put them all on the same line. We can do that pretty easily though. So cout array equals, and then maybe a curly brace just to be pretty. And now let's have a for loop that prints out each item. There's something bugging me about this. Tell you what. Take away that curly brace. We're not going to care too much about separating them by commas and stuff like that. Okay, so same idea. For int I equals 0. For parentheses int I equals 0. I less than the size. I plus plus. Cout nums subscript I. Cout nums square brace I in brace followed by a space, just to put some space between each item in the array. And then once we're done with the for loop, we're going to write out an ENDL. Okay, I think it'll work. Yeah, there's our array printed as a list of numbers. Good for eyeballing. Now I haven't printed out my max yet, right? I called the max function, but I never printed it out. So I'm going to scroll down here, and then after I call out max nums and I print the nums, I'm going to print the max. So cout arrow arrow max of nums equals space end quote arrow arrow max num arrow arrow ENDL. Okay, if you run it and it works, that's awesome. And I want you to write a min function. Just take that max function, copy it, and paste it, and make it a min function. And I'll do it, of course, with y'all in a minute. But I'm going to walk around and make sure that nobody's got any syntax errors in the meantime. So I run it. It says my maximum is 345. I believe it. There's that 345. Looks like the largest number to me. Okay, good. So there's my print array function. And there is my max function. It'd be really cool if I could get them both on the screen at the same time, but kind of doubtful of that, unless I shrunk it down just a little bit. And put some braces on, you know, the same line rather than the one above it. Close enough, huh? All right. So we've got max working. Min is so similar. All you need to do is change that sign right there. But also we ought to change the name, right? Highest doesn't make any sense anymore when it's min. So I am going to type it in again. But what you could do is you could just copy, paste, change max to min, and then change the word highest to lowest. Right? That would do it. That'd be the fastest way of doing it. But I'm going to go ahead and type it because I'm a glutton for punishment. Int min, I'm passing in an array. Int nums subscript, comma, int size. And now I need to declare a variable. We're looking for the lowest, not the highest. So int space lowest equals nums subscript 0. For int I is equal to 0, I is less than size, I plus plus. Now our if statement. If our lowest, our current lowest, if lowest is greater than the number we're looking at, num subscript I, if lowest greater than num subscript I, then lowest equals nums subscript I. And you know that ternary operator business? I'm going to play with typing something and see if I like the way it looks. I probably won't. Lowest equals lowest greater than num subscript I question mark num subscript I colon lowest. Okay, that just looks absurd. You could write it using a ternary operator. This is one of those cases where that's just use an if statement. Never mind. Okay, all right. And then we're going to return our lowest. So that's our lowest function. That's our min function. All right. So now I'm going to write a sum. It's going to look very similar, right? Except instead of checking an if and a lowest, it's just going to be adding values to a total. So int sum, and then the same business. int nums subscript in subscript, comma, int size in parentheses. We need a variable to hold this stuff. So int total equals 0. our for loop again, same for loop we've been typing the other 2 times. For parentheses int I is equal to 0, I is less than size, I plus plus. And then total plus equals nums subscript I. And then we can return that total. I'm going to take out the square braces there. Just, this is not strictly necessary. And so those are our 2 new functions. A lot of list processing, a lot of array processing follows that same general paradigm, right? If you wanted to put a count function, you would just keep adding to the count only when the value matched the value of nums, subscript I. So we could do a count function. Maybe we ought to. Why not? We're on a roll. So one more of these. Int count. It's going to take an array and it's going to take a size, but it also needs a value to find. So I'm going to call it target. Int target, parenthesis, or excuse me, int target, comma, int num subscript in subscript, comma, int size. Now we need a counter, so I'm going to call it, I don't know, int c is equal to 0. Now our for loop. Getting real tired of typing it, just go and copy it from here. For int I is equal to 0, I is less than size, I plus plus. Curly brace. If nums subscript I equals our target, then count plus plus. Or excuse me, C is what we called our variable. C plus plus. Hey, that looks funny. All right, and then return our counter at the end. All right, we need to test those functions. That stuff we commented out, go and uncomment it and print the return values out. So just scroll back down to main, uncomment those lines that we commented, and print the return values out. Anybody still need this count function on the screen? It's okay if you do. All right, going to scroll down. Going to go down to main. All right, so int minnum is equal to minimum of the nums, comma size. Int sumnum is equal to the sum of nums, comma size. And int count num is equal to count. And what number am I going to look for? I like the number 3. I want to see how many times the number 3 appears in mine. 3, comma, nums, comma, size. And then now I just have 3 more print statements to do. Cout min equals end quote arrow arrow minnum endl, and it's going to get kind of tedious typing all that, so I'm just going to copy and paste it. So min is equal to sum is equal to the sum of the nums, sum num, and then the count of 3, because that was my favorite number, just put your own number in there, is equal to the count num. Then run it and see what it does. Alright, there are 4 3s in here that I eyeball, so my count function is working right. I'm not going to add them up and right, in my head. Minimum is in fact 1. Makes sense to me. Okay, so it looks like good code. Looks like our code is working. Now, if you've taken me in another class, don't answer, but have we talked about parallel arrays yet? Yeah? Okay, good. Kind of figured we had, but since we started veering off into classes and structures, I lost track a little bit. Well, that's not where we really were. So what is a partially filled array? A partially filled array is when you don't know in advance how much data the array will be holding. Like if I was going to write a program to print out all of our names, everybody in the class, but I really didn't know how many people were in it, right? And I didn't want to have to modify the program every time somebody got a new class with the exact class count. So what I might do is I might assume that, okay, in rows you're never going to have more than 100 students in a class. We might allocate our array out to 100 students. But then if there's only 12 students in the class, right, then what are you going to do with all the rest of that space? When you print them out, you don't want to print out items 13 through 100 or whatever. So we're going to kind of simulate that, not with numbers that large. That's kind of obnoxious. But let's go, and if I could find my code, it'd be awesome. All right, so down here above our pause, we're going to create an array called strings, and it's going to be large enough for, say, 6 strings, but we're only going to put, or 10 strings, but we're only going to put a few strings in it. So string names subscript 10. Now we don't even have any data in it yet. Let's write a little print function, not function, a range-based for loop. So for parentheses string v colon names. This is just to see what we've got in there. We know what we've got in there. It's nothing, right? C out, arrow, arrow, name. This is a bad way of doing it. I should have used a for each loop, and I apologize for that. And I should have declared the size of the array. So let's do both of those things. Above string names, we're going to do constant int. Or I could, just do the size calculation that we were doing that. Let's do that. So size is equal to size of parentheses names into parentheses divided by size of the first element in the array, which is names subscript 0. Now we know the maximum size. So for, guess what we're going to type? Int I is equal to 0, I is less than size, I plus plus. Now let's see out, arrow, arrow, I. Let's print out our index counter. And then arrow, arrow, and then the value at that position. Name subscript I, arrow, arrow, ENDL. Now we don't have any data in this array, so I'm real curious as to what it's going to print out. Alright, you see that? It didn't really print out anything. In Java, we would have seen a list of word null there, but we didn't see that here. But if these were numbers, for example, well, let's I think I'm just going to run with it like that, but then we'll do an example with numbers. Okay, so we're going to wind up using this for loop a lot. I'm going to narrow it down a little bit. I'm going to take out that curly brace and that curly brace so that when I copy and paste it, I only have 2 lines I need to paste. Okay, so let's put some names in there. So name subscript 0 is equal to Joe Bob. Name subscript 1 is equal to Billy Bob. Name subscript 2 is equal to Jim Bob. And let's print them out again. So copy and paste that for loop. Okay, so you see when I ran it and I printed it, it knows that element 0 is Joe Bob, element 1 is Billy Bob, element 2 is Jim Bob. The rest of this is invalid data. We don't want to print numbers out for names we don't have. You know, and it'd be even worse if we were trying to like calculate the sum and the average. Because we really only have 3 pieces of data. Add up 3 pieces of data and then divide by 10? No, that's not good. That's not how you calculate the average. So this is what's known as a partially filled array, right? It's got 10 items, but it's only got 3 pieces of data in it. So when you're dealing with partially filled arrays, there's a couple of solutions. What you normally do is you use a variable that indicates how many items you have added to it. So, if we were going to do that, let's just repeat this process here. Names, but we're going to declare a counter. Int num names is equal to 0. And now every time we add a name, we're going to increment that. So name subscript 0 is equal to Daffy. Num names plus plus. Name subscript 1 is equal to Casper. Lamest cartoon ever. Alrighty. And then num names plus plus. Name subscript 2 equal to Dizzy. Num names plus plus. And let's add it one more. Name subscript 3 is equal to Sleepy. Apparently the 7 dwarves have come over here. And then num names plus plus. Right. So every time we've added a piece of data to it, now we know how many names are in it. Now, really, is this how we would have handled it? No, we probably would have used a loop. We would have been asking the user for this information. But take your for loop again, copy it, paste it, but make a change. We're not going to go out to size anymore. We have a counter of how many pieces of valid data we have. Num names. That's our counter. If we were going to go and put more elements into our array, we would increase num names. Now, num names had never better become greater than 10, right? Because 10 is the length of the array. Better not. But that lets us track how many names are in our array. And after we added those 4 names, seems like I've got an error here. Daffy, Casper, Dizzy, Sleepy. Nope, nope. So it printed it out correctly. It printed out 4 names, rather than printing out 4 names and then a bunch of empty data. That is the idea behind a partially filled array. You don't know how much data is in there. Or what I mean is the amount of data in there might vary. You know, one semester I might have 27 students in this class. Another one I might have 12. When I'm doing my data entry, I just want to only print data for the values that I have. Let's do that one more time, but with like some kind of series of numbers. So int nums. No, I've already used nums. All right, prices. Subscript 10. We're going to be adding up 10 prices. And then we need a counter for our prices. Int num prices is equal to 0. Then we're going to have a for loop. We're going to let them enter prices as often as they want, but if they ever type in -1 as a price, we're going to exit out of the loop. So we're going to need to be careful. We need to make sure that we don't go past the number of prices, which is 10, the maximum price. Maximum number of prices, the size of the array. And we also want to make sure that we don't let them stop when they want to. So I think what I'm going to do is I'm going to use a for loop. First, let's calculate the size of our array. We know how to do this. Size equals size of prices divided by size of, and I should have made these prices a float, right? Because prices aren't always whole numbers. But anyway, size of the first element in the array, prices subscript 0. And by the way, that's why you do it like this, because if you change that data type, this calculation still works. But I'd like for these prices to be floats or doubles. So I'm going to come up here and I'm going to change that word to double right there. So let's do a while loop. While num prices is less than the size of the array, while num price is less than size, we're going to ask the user for a price. And then if they enter a special sentinel value, we're going to break. So cout, please enter price, arrow, arrow. And I'm going to do this in a strange way because I'm just kind of mistrustful of something. I'm going to put this inside parentheses. And then arrow, arrow, ENDL. And inside those parentheses, I want to do num prices plus 1. Why am I doing that? Because the user doesn't want to see something that says enter price number 0. That's not the way normal people think. Computer programmers, yeah, it makes sense. Price number 0, I know what that means, but it doesn't make sense for a normal user. So we're going to add 1. There. But let's tell them that they can type in a negative number to stop it. Cout, arrow, arrow, or -1 to stop. \n. So now we need to get that price. Double D, CIN, arrow, arrow, into D, CIN, arrow, arrow, D. And if they typed in a -1, we don't want to do anything. If D is equal to -1, then break. Otherwise, let's put it in the array. Prices, subscript, num prices, I kind of wish I'd chosen a shorter variable name, equals the value they just typed in, D. I'm kind of disgruntled with using a single letter variable name. I wish I'd called it input or something like that. Maybe I'll do some copying and pasting to fix that in a minute. And then lastly, we need to increase the number of prices by 1. Num prices plus plus. Right? Because now we've got a good piece of data. Okay, what could we do to clean up this code? I don't want to declare this variable inside the while loop, so I'm going to wind up cutting that double D and pasting it above the while loop. And I really wish I had a better name. I wonder if I can change that. Can I just highlight this like you can in Java, right-click, and no, I'm not seeing that. Alrighty. So, I wish that was called input. So I'm changing that D to input, and I'm changing all references to D to input. Just because it makes more sense, right? Single letter variable names are lame. Then take that double input, cut it, and paste it way up at the top. Not way up at the top, but like up here underneath the, you see where I put it? That's a good enough place for it. Alrighty, I think it's good to go. I wish I had made this an array of ints because we already have all those functions for ints, right? And we would have to go back and we would have to change them to arrays of floats and stuff like that to get this to work. But having not thought ahead. All right. Please enter price number 1. I'll type in a price. 0.99. Enter price number 2. 20.01. Price number 3. 90. 50. 65. 52. I'm getting tired of typing stuff, so I'm going to type in -1. All right. I should have kept going just to make sure it didn't write past the end of the array, that it stopped after doing 10 of them. And also, we're not printing the array out. Okay. Since I so deeply regret not having made this an array of integers, we're going to change it. We're going to live in a world where prices are in whole numbers only. So, up here, these 2 lines where they say double, change their data types to INT. 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 Now let's print our array out. Print prices, comma, but we're not passing in the size, right? Because size is 10. But there may not be 10 pieces of data. There may only be 1. So we're going to pass in prices, comma, num prices. And then let's get the sum of the prices. Int sum price equals sum prices, comma, num prices. And yeah, we could do the other ones. We could get the minimum and the max, right? INT min price is equal to sum, or excuse me, min of prices, comma, num prices. And we could print those pieces of data out. Cout max price equals arrow, arrow. Well, I didn't calculate max price, right? Min price equals, quote, arrow, arrow, min price, arrow, arrow, ENDL. And then cout, arrow, arrow, quote, sum of prices equals, arrow, arrow, sum price, arrow, arrow, ENDL. So what's the big difference between these calls up there when we first called them and here? What have we done differently to account for the fact that these may be partially filled arrays? When I called sum up higher, I called sum of nums, but then what did I pass in as its parameter? The length of the array, the maximum length of the array. Here we're passing in the number of items that we are sure are actually filled. Because we don't want to add up, we don't want to look through the entire list for the minimum if only the first 3 items are good. We don't want to print out all 10 if only the first 3 are good. So that's why we kept track of the number of items with this num prices plus plus. Give it a shot, and then I'll do walkabout. All right, please enter price 1. 100, 200, 50. And I'm tired of it. I've entered 7 of them. I don't want to enter any more, so I'm going to type in -1. And it tells me my list of prices. Same order. It tells me the minimum that I've entered, and it prints out the sum. So that's the deal with partially filled arrays. In Python, you probably didn't have to mess with partially filled arrays. The reason I say that is because you use lists, right? And you only added items to the list when you had a piece of data. You never had a list that had 10 items in it, but you only cared about the first 3. Anybody need help typing? Is it working for everybody? Look me in the eyes and tell me it's working. All righty. We'll keep going. So you have to use a counter variable to keep track of the number of items that are stored. How about comparing arrays? To compare to arrays, you have to check element by element. You use a for loop for I is equal to 0, I is less than size, I plus plus, and then you do if A subscript I not equal to B subscript I, then you know there's a problem. So here they go. Here's how they wrote it. They have something called first array. And sure enough, it's got some data in it. Second array. And then they have arrays equals true. That's our flag. They're assuming that it's okay. It's innocent until proven guilty. And then we have a loop counter. And then we compare the 2 arrays. If we ever find something that doesn't match, we set arrays equal to false. And then we can check the result of that Boolean variable. Let's do that. Let's declare 2 arrays. Just give them like 5 values. I don't know. Int, or are we tired of numbers yet? Do we want names? Ints are great, huh? A1 for array 1 is equal to, and then just give us, 5 values. And then copy that and paste it and make it int A2. Now let's assume that these arrays are of the same length. So let's just calculate our size. You probably already remember how to do this. Got to do size of. Size is equal to size of A1 divided by A1 subscript 0. Nope, that's wrong. Size of A1 in parentheses divided by size of A1 subscript 0. Let's print out our arrays. So let's see out the string A1 equals, and then call our print function. Print A1, comma, size. Just so we see what we're dealing with. Did I have to put them on the same line? No, but I happen to know that the print statement, I guess I'm going to undo that. That's too cheesy. Okay. And then let's print out A2 the same way. Cout, arrow, arrow, A2 equals, end quote, semicolon. And then print, parentheses, A2, comma, size. Now let's write a loop that'll check to see if they're equal or not. We're going to create a flag. We're going to set it to true. And then we're going to use a for loop comparing the items. And if it ever finds one that don't match, we're going to set the flag to false. So that flag is going to be a Boolean. Bool, I'm going to call it match, equals true. The arrays match, so we think. Now let's write a for loop. Same thing, we could do this in our sleep by now. For, parentheses, int I equals 0, I less than size, I plus plus, curly brace. So we need to check to see if they're equal, and if they're not, we need to set match to false. So if A1 subscript I not equal A2 subscript I, then it's a problem. Then match equals false. Now let's just write a little if statement. If match, cout, arrays are equal, /n, else cout, arrow, arrow, arrays are not the same, \n. Now, we wound up not using range-based for loops for a lot of this stuff, and that's because a lot of these things required index. I had to have indexing here to compare these two. Just like when you have parallel arrays, you can't use a range-based for loop. You need that index number to compare the two arrays. The same as here. These are kind of parallel arrays in a way, right? They're of the same length. The items are kind of related to by their index number. So we couldn't use a range base. We had to use a for index loop there. When we were doing data entry, we needed to do it within a we needed to do it with the index, so we did not use a range base. And it turns out we haven't used the range base a single time in this assignment, and that's okay. Alrighty, it's wanting me to enter some data. I'm just going to type in one number and then type in -1. And there we go. I need to increase the size of this. Not looking very easy to see. Alright, it said the arrays are equal. Yeah, that's just because I copy and pasted them. Once yours runs and says that they're equal, go in and change one of the values. Like I had this number 23 here, I'm going to make it 33. Something like that. And then run it again and see if it says that they're the same or not. Okay, and the arrays are not the same. Alright, I think that's about as far as we're going to take it. Let's look at the next slide. There's already a Dropbox made, so you can put your CPP file there. Using parallel arrays. Okay, we have talked about that. So we're ahead of the game. That's where we will pick up on Tuesday. And what's our schedule going to be? Tuesday we're going to talk about stuff. Thursday we'll review for the final, and then we come back the next week and we actually have our final. Do we know our date for the final?
15th.
All right. Yep. All right. Okay. So go ahead and take your CPP file, and I'll do a walkabout for those of y'all who still are confronting errors.
So it's letter T.